Hello children. Today we are going to discuss about division of a polynomial and the last concept and last model in the concept of division of a polynomials. In our last class we have seen how to divide the polynomial with another polynomial, and we have seen whether the divisor is a factor of the dividend or not. That is from exercise 2.3. First Roman we have completed, second Roman we have also completed. Here we have another important model, that is example number 9. Find all the zeros. What is the question? Find all the zeros. All the zeros, all means how many? As we know that the number of zeros are depending on the degree of a polynomial. The number of zeros are depends on degree of a polynomial. Now what is the polynomial given? 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. This is the polynomial as well. Which degree polynomial it is? 4th degree polynomial. Which degree polynomial it is? 4th degree polynomial. 4th degree polynomial means then how many zeros we have? 4 zeros. They are asked to find all the zeros. Then how many zeros we have to find? 4 zeros we have to find. Next, if you know that 2 of its zeros are root 2 and minus root 2. 2 of its zeros are root 2 and minus root 2. Total how many zeros we have? Total we have 4 zeros. In that how many we know? 2 zeros we know. Then how many we have to find? 2 more we have to find. So the given polynomial is having 4 number of zeros. Out of 4 we know 2 zeros, root 2 and minus root 2, and remaining 2 we have to find. Now our concept is how to find those 2 zeros. How to find those 2 zeros. Here we can go for 2 methods. One is using factor theorem. Using factor theorem. What is the factor theorem? We can substitute one value of x in the given polynomial. Where we get the 0, that is nothing but 0 of a polynomial, as we know the concept. That is one way of method. The another way of method, using the given 2 zeros. Using the given 2 zeros, then we can find the other 2 zeros by applying the division. So we have methods 2. The first method, substituting one value in the given polynomial and we check where we have the answer 0. That is one way of method. The method 2, I know 2 zeros. Using these 2 zeros, by applying the division method, I can find another 2 zeros. Now let us see how to find it. So how to use these 2 zeros? How to use these 2 zeros, that we have to know. Now, as I know that they said that alpha is root 2, means x is equal to root 2 is a solution for this polynomial. X is equal to root 2 is a solution for the given polynomial. X is equal to minus root 2 is also a solution for this polynomial, because they given that root 2 and minus root 2 are zeros. Root 2 and minus root 2 are zeros of this polynomial. when root 2 and minus root 2 are zeros of this polynomial, means x is equal to root 2 and x is equal to minus root 2 are the solutions. When x is equal to root 2 comes here minus root 2. So we have x minus root 2. Here minus root 2 comes this side plus root 2. So x plus root 2 are the factors of the polynomial. This concept you have to know that. So when they said that root 2 and minus root 2 are zeros of a polynomial, plus root 2 comes this side minus root 2. So you have x minus root 2. Minus root 2 comes this side plus root 2. So that x plus root 2 is also factors of the given polynomial. So when we have the degree 4, we have 4 factors. When we have 4 factors, automatically what we have? We have 4 zeros. So from the factors we get the zeros. From the factors we get the zeros. From the zeros we get the factors. Here I know the zeros so that I am able to form a factors. Now I will come for another example. When I have 24 is a number. 24 is a number. For 24, what are the factors we have? What are the factors we have? 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, 12 is a factor, 24 is a factor. All these are factors of 24 because 24 ones are 24, 12 twos are 24, 8 threes are 24, 6 fours are 24. All these are factors of 24. All these are factors for 24. Now one small example. When 2 is a factor for 24, 3 is a factor for 24. When 2 is a factor and 3 is a factor, then 2 into 3, that is equal to 6, is also a factor for 24. Hope you understood. When I am talking a number 24, these are the factors for 24 I have. 1, 2, 3, 4, 6, 8, 12, 24. In this is one example to understand. 2 is a factor, 3 is also a factor. So that the product of 2 and 3, 2 3s are 6, is also a factor for 24. Now you may ask that, sir, 12 is a factor of 24, 8 is also a factor of 24, then 12 8s are 96. 12 8s are 96 is also a factor of 24, no sir. But here what you need to understand here, right? 2 and 3 are co-primes. 2 and 3 are what? Co-primes. But here 8 and 12 are not co-primes. 8 and 12 are not co-prime because here for 8 and 12 the HCF is how much? 4 is the HCF. For 2 and 3 what is the HCF? 1 is the HCF. That's why these two are called co-primes. Here 8 and 12 are not co-primes. So these are the prime factors. 2 and 3 are what? Prime factors of 24. 2 and 3 are prime factors of 24. When 2 is a prime factor of 24, 3 is a prime factor of 24, then 2 3s are 6 is also a factor of 24. 6 is a factor of 24. Why I am explaining this concept means, now here I have x minus root 2 is a factor, x plus root 2 is a factor. So that x minus root 2 into x plus root 2, that is x square minus 2, is a factor of polynomial. So I know that x minus root 2 is a factor, x plus root 2 is another factor. The product of these two factors, x square minus 2, is also a factor of this polynomial. In second Roman, we have done the division method. Check whether the first polynomial is factor of second polynomial or not. In that, what we have done, when the first polynomial is factor of second polynomial means we should get the remainder 0. Here also you will get the remainder 0. Now let me explain. Solution. Given polynomial is p of x is equal to 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. Degree of p of x is 4. Number of zeros for p of x are 4. Given zeros are root 2 and minus root 2, that is x is equal to root 2 and x is equal to minus root 2 are the solutions of p of x. That implies, as I told you, plus root 2 comes this side, minus root 2. So x minus root 2 and minus root 2 comes this side, plus root 2. X plus root 2 are the factors for p of x. So x minus root 2 and x plus root 2 are the factors for p of x. That implies x minus root 2 into x plus root 2 that is equal to x square minus 2 is also a factor for p of x. So what is the given polynomial? This is the polynomial given for us. What is the degree of the polynomial? 4. When the degree is 4, how many zeros we have? 4 zeros. What are the zeros are given? Root 2 and minus root 2 are given. When root 2 and minus root 2 are zeros means x is equal to root 2 and x is equal to minus root 2 are the solutions. When x is equal to root 2 is a solution, plus root 2 comes this side, minus root 2. So x minus root 2. X is equal to minus root 2 is a solution. Minus root 2 comes this side, plus root 2. So x plus root 2. These are the factors for p of x. When these two are factors means the product, So x minus root 2 into x plus root 2, x square minus 2 is also a factor for p of x. Now we are going to apply the division. So here I have a second degree polynomial. With this second degree polynomial, I am going to divide the fourth degree polynomial. Now let us see how to divide it. Now let us come for division. Now what I am doing now, 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. This I am going to divide with x square minus 2. I am going to divide with what? X square minus 2. Now you can observe here, it is a complete polynomial. As I told you in our previous class, before going to apply the division, first we should check the divisor and dividend whether they are complete polynomial or incomplete polynomial. Here I have x power 4 term, next x cube term, next x square term, next x term, next constant, which is a complete polynomial. Whereas the divisor, when you will observe, I have x square minus 2. I have x square term and I have a constant. In between, I don't have the x term. I don't have the x term. So when we don't have complete polynomial, what we have to do? We should make them into complete. Now it is an incomplete polynomial. Let us convert into complete polynomial. How to convert it? As we know that x square plus 0 into x minus 2. So x term we are taking with 0 coefficient. Now I have x square term and I have x term and I have constant. So which is a complete polynomial. Now let us start the division. As we know that step 1. What is our step 1? The first term of the dividend 2x power 4 and the first term of the divisor x square. When we calculate here, what I will get? 2x square will come. So let us write that 2x square in quotient place. Step 2. What is step 2? With this quotient 2x square, we are going to multiply the divisor. That is x square plus 0 into x minus 2. 2x square into x square. 2x power 4 plus into plus 2 zeros are 0, x square into x cube plus into minus 2 2s are 4, x square. Now what is the value we have? 2x power 4 plus 0x cube minus 4 x square. Now let us change the signs, minus and plus. Plus 2x power 4 minus 2x power 4 can get cancelled. And minus 3 minus 0. We have minus 3 x cube. Plus 4 minus 3. So plus x square. Now we should get down plus 6x. Next, again we should repeat the same procedure. What is the step 3? Now, the first term of the dividend 3x cube and first term of the divisor x square, we have minus 3x. Let us write that minus 3x in quotient place. Next, step 3. Step 4. With this quotient minus 3x, we should multiply the divisor. That is x square plus 0 into x minus 2. Let us multiply. Minus into plus minus 3 x into x square x cube minus into plus minus 3 zeros are 0 x into x square minus into minus plus 3 2s are 6x. Now what is the answer we have? Minus 3x cube minus 0x square and plus 6x. Now, changing of the signs, plus, minus. Minus 3x cube plus 3x cube can get cancelled. Here x square and 0, so you will have 1x square, means x square. Plus 6 and minus 6. 6 minus 6 is how much? 0 into x. And now we get down the minus 2. Now what I have? X square plus 0x minus 2. Again let us continue the steps. Now step 5. What is step 5? The first term of x square and here the first term of x square divided. So x square by x square is equal to 1. So here I should write the quotient 1. Now step 6. With this quotient 1, we should multiply the divisor. So x square plus 0 into x minus 2. When we multiply 1 into x square, 1 into 0 into x, 0x, 1 into minus 2 is minus 2. Now what we have? X square plus 0 into x minus 2. Again change of the signs, minus, minus, plus. Plus x square minus x square cancel. Plus 0 minus 0 cancel. Minus 2 plus 2 cancel. Total what we have? 0. As we know that x square minus 2 is what? Factor. When it is a factor for this polynomial, definitely our remainder must be 0. Suppose if you unable to get the 0 as remainder, your calculation is wrong. 100% we should get the remainder 0. If you are unable to get the remainder as 0, your calculation is wrong. So you should check once again. Now it is very clear. This is the divisor, this is the dividend, this is the quotient, and this is the remainder. Okay sir, up to now we understood. This is our regular procedure. Now how to find another two zeros? Now that is my problem. They asked to find all the zeros. All the zeros means I have 4 zeros. In the 2 zeros are given in the question itself. Now I need to find 2 more zeros. Then how to find 2 more zeros? How to find 2 more zeros? Now let me explain. Now when we have 21 is a number, if it is dividing with 3, let us go for 3 table. So in 3 table, 3 sevens are 21, we have the remainder 0. When we divide with 3, we are getting the remainder as 0. Then what I can say? I can say that 3 is a factor of 21. 3 is a factor for 21. At the same time, 7 is also a factor for 21. Am I correct or not? 3 sevens are 21, then 7 threes are also 21. Means 3 and 7 both are factors for 21. Similarly, for example, when we go for 16, let us divide with 2. 2 8s are 16. I have a remainder 0. Now I can say that 2 is a factor for 16. 8 is also factor for 16. Now by understanding these two examples, here I got the remainder 0. Then I already know that x square plus x minus 2 is factor for the polynomial p of x. At the same time, here the quotient, it is also a factor for this polynomial. So the quotient 2x square minus 3x plus 1 is also a factor for this polynomial. Is also a factor for the given polynomial. That we need to know. Now when we go for factorization of this quotient, automatically we will get another 2 zeros. With this divisor we have 2 zeros. Now with this quotient we have another 2 zeros. So total what I have? 4 number of zeros we have. So we have to know that this quotient 2x square minus 3x plus 1 is also a factor for the given polynomial. That we have to understand. Now we can factorize this so that we have another 2 more zeros. Now let us factorize it. We know that dividend is equal to divisor into quotient plus remainder. That is p of x is equal to x square minus 2 into 2x square minus 3x plus 1. That is 2x square minus 3x plus 1 is also a factor for P of x. Now factorize 2x square minus 3x plus 1. Now let us go for factorization. How to factorize? As we know that here x square coefficient is how much? 2. Here constant is how much? 1. 2 ones are 2. So I have 2 ones are 2. The 2 again I can write as minus 2 into minus 1. So that minus into minus plus 2 ones are 2. By adding minus 2 and minus 1, I can get minus 3. That is 2x square minus 2x minus 1x plus 1. Means splitting method. We are splitting minus 3x as 2 terms. Now from the first 2 terms, I can take 2x common. Let us have x minus 1. From the next 2 terms, I can take minus 1 common. Let us have x minus 1. Again here x minus 1 and x minus 1. Taking x minus 1 as common. Here I have 2x and here I have minus 1. So 2x minus 1. So what are the factors for this? X minus 1, 2x minus 1. Let us take them 0. That is x minus 1 is equal to 0 and 2x minus 1 is also equal to 0. That implies x is equal to 1 and x is equal to 1 by 2. Now what are the x values we have? I got x value as 1 and x value as 1 by 2. What are these x values 1 and 1 by 2? They are the zeros of the given polynomial. So already I have 2 polynomials and these are the remaining 2 polynomials. Therefore the zeros of the given polynomial are, what are the zeros? I have root 2 and I have minus root 2 and I have 1 and 1 by 2. So total I have 4 number of zeros. Root 2 is 1 0, minus root 2 is another 0, plus 1 is another 0 and plus 1 by 2 is another 0. This is the procedure we have to follow to get all the zeros of a given polynomial. This is an important model and this is the last model in our chapter. Now based on this we have one more exercise problem. Let us finish that exercise problem also. Now let us have another problem in the same model from exercise 2.3, question number 3. Find all the zeros 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. If you know that 2 of its zeros are root 5 by 3 and minus root 5 by 3. Just like our previous problem. There also they have given a 4th degree polynomial and they have given plus root 2 and minus root 2 are the 2 zeros. Then ask you to find out the 2 zeros. The same procedure we have. Let us see how to solve it. Solution. Given that, what is given for us? They have given a 4th degree polynomial 3x power 4 plus 6x cube minus 2x square minus 10x and minus 5. What is the degree of this polynomial? Degree of P of x is, what is the degree? 4th degree. When it is 4th degree polynomial, how many zeros will have? Number of zeros of P of x are 4. Out of 4, how many zeros we know? Root 5 by 3 and minus root 5 by 3. Given zeros are root 5 by 3 and minus root 5 by 3. That is That is, when we know, for example, it is 1 0 and it is another 0. If you have it is alpha, if it is have beta, alpha into beta. In the initial stage, we had a discussion about one concept. When we know two zeros alpha and beta, how to find the polynomial? When we know alpha and beta are the two zeros of a polynomial, how to find the polynomial also we know. That is k into x square minus alpha plus beta into x plus alpha into beta. This is the polynomial we have. Previously, we have done directly because I don't have fractions. Whereas here I am having fractions. That's why I am using this method. Don't confuse. Even for previous problem, you too can apply the same procedure. Nothing will happen. Example I have done direct method. Now here I am explaining with formula. Both are suitable methods, and the formula method you can apply even for the previous example one also. Nothing to worry. Now k into x square minus alpha plus beta into x plus alpha into beta. That is k into x square minus alpha. This is entire is alpha and this is entire is beta. Now what happens here? Root 5 by 3 minus root 5 by 3 into x plus alpha into beta. Root 5 by 3 into minus root 5 by 3. Now let us see here k into x square. Here plus minus both will get cancelled. So there is no x term. And when it comes to here, plus into minus, minus root 5 by 3 into root 5 by 3, we have 5 by 3. When we take LCM inside, we have 3 is the LCM. So 3 into x square, 3x square minus 5. 3x square minus 5. When I have 3x square minus 5, let k is equal to 3. Let k is equal to 3. When I have taken k is equal to 3, what happens here? K and 3 both can get cancelled. Then finally what I have? 3x square minus 5. So let k is equal to 3. Then we have 3x square minus 5 is a factor for p of x. So when we have taken k is equal to 3 can get cancelled. Finally what I have? 3x square minus 5. So this 3x square minus 5 is nothing but what? Factor for the polynomial p of x. Next, what we are going to do? Now we are going to apply the division. Now let us divide the given polynomial fourth degree one with the second degree one. Now, with 3x square plus 0 into x minus 5, I am going to divide the fourth degree polynomial 3x power 4 plus 6x cubed minus 2x square minus 10x and minus 5. With this, I am going to divide the fourth degree polynomial. Now let us have the steps. Step 1. What is step 1? The first term of the dividend, first term of the divisor. These two we have to do. So first term 3x power 4 by first term of the divisor 3x square. 3 can get cancelled. We have x square. So in quotient I am writing what? X square. Step 2. What is step 2 here? What is step 2? With this quotient x square, with this quotient x square. I should multiply the divisor. What is the divisor I have here? 3x square plus 0 into x minus 5. Let us multiply x square into 3x square. X square, because what is the constant we have? 1. 1 3s are 3. X square into x square. X power 4. 1 zeros are 0. X square into x cube plus into minus minus 1 5s are 5 x square. So what I have here? 3x power 4 plus 0x cube minus 5x square. Now we should subtract. Let us change the signs. Minus, minus and plus. So plus 3x power 4 minus 3x power 4 can get cancelled. 6 minus 0, 6x cube plus 5 minus 2, 5 minus 2, 3x square. Now let us get down minus 10x. Let us get down minus 10x. Next again, step 3. What is step 3? Now the first term of the dividend, first term of the divisor. So 6x cube by 3x square. 3 1s are 3 2s are 2 into x will come. So I have plus 2x in quotient place. Next, step 4. What is step 4? With this quotient 2x, I should multiply the divisor. So 3x square plus 0 into x minus 5. 2 3s are 6. X into x square, x cube plus 2 zeros 0, x into x square plus into minus minus 2 5s are 10 x. So what I have here? 6x cube plus 0x square minus 10x. Now again go for subtraction, changing of the signs. Minus, minus and plus. Plus 6x cube minus 6x cube can get cancelled. 3 minus 0, 3x square. Now minus 10 plus 10, how much? 0 into x. Now get down minus 5. Now what I have here? 3x square plus 0 into x minus 5. Next again, step 5. Step 5. What is step 5? With this first term by first term of the divisor. So 3x square by 3x square. Both can get cancelled. What is our answer? Plus 1. So write this plus 1 in the quotient place. Next, step 6. What is the step 6? With this quotient 1, with this quotient 1, we should multiply the divisor, means 3x square plus 0 into x minus 1. So 1 into 3x square, 3x square, 1 into 0, 0 into x, plus into minus, minus 1 5s are 5. Now let us write here. 3x square plus 0 into x minus 5. Now changing of signs again. Minus, minus, plus. Now let us see here. Plus 3x square minus 3x square cancel. 0 minus 0 cancel. Plus 5 minus 5 cancel. What I have? We have the remainder is 0. Now as we know that we have seen example 9, previous example. When we got the remainder 0, we can say that the divisor is a factor for this polynomial. Quotient is also a factor for the polynomial. Now what is the quotient? X square plus 2x plus 1. Now let us go for factorize of this. Now we are going to factorize of the quotient. We know that what we know, dividend is equal to divisor into quotient plus remainder, that is the dividend p of x is equal to divisor. What is the divisor? We have 3x square minus 5. What is the quotient? We have x square plus 2x plus 1. What is the remainder? We have 0. No need to write. So from this statement, that is x square plus 2x plus 1 is also a factor for p of x, is also a factor for p of x. Now factorize x square plus 2x plus 1. Now to factorize this, simply I can write it as x plus 1 whole square, that is nothing but x plus 1 into x plus 1, because it is in the form of a plus b whole square. A square plus 2ab plus b square, I can write it as a plus b whole square. Now what I have here, x plus 1 whole square can be written as x plus 1 into x plus 1, that is x plus 1 is equal to 0 and x plus 1 is equal to 0. That implies x is equal to minus 1 and x is equal to minus 1. Now what are the values of x? We have minus 1 and minus 1. These minus 1 and minus 1 are nothing but what? Zeros of a polynomial. Already we know two zeros. What are they? Plus root 5 by 3, minus root 5 by 3. These are the two zeros. Another two zeros, what we have? Minus 1 and minus 1. Now you may ask that, sir, minus 1, same values, now how can we take? So the zeros may be equal. You may have same zero several times also. There is no problem at all. So therefore zeros of a given polynomial are, what are the zeros we have? The first zero I have root 5 by 3. Next what I have? Minus root 5 by 3. Next I have minus 1 and minus 1. These are the total 4 zeros we have for the given 4th degree polynomial. So with this problem successfully we have completed our second chapter, polynomial. So try to understand these two models. Let us finish your class 1. And here we have optional exercise. Optional exercise is also important for us. In rare cases we are getting problems from optional exercise also. So that we have to discuss optional exercise problems also, that I will give you a notes. You can try to copy and try to understand it. Next class we can discuss another new concept of our class 10th syllabus. Hari Om. Thank you.